Hey everyone, welcome back to another lesson for Neural Notes. By the way, guys, if you're enjoying this course, learning a lot, please be sure to like, share, subscribe. You're gonna support our channel and help us grow our audience so more and more people can learn about machine learning in interesting ways. For today's lesson, we're going to be talking about feature engineering. So, firstly, what is kind of feature engineering? I want you to imagine like you hear a song playing from another room. Now it might be kind of muffled, but you can kind of tell what instruments are playing, whether it's a deep bass, a bright synth, or a sharp snare. But how, right? In music production, you can tell these things because one sound isn't different from another because of just one thing. It's a combination of distinguishing factors like pitch, harmonics, attack, and tone that your ears have naturally developed by hearing so much to be able to tell different things apart. And these different things we call are features. And in machine learning, um, before an AI can really learn these patterns, we need to extract meaningful features from raw data, just like how we analyze different aspects of sound when producing. And so I want to kind of explore feature engineering through music production and break down the sound into useful features, the way machine learning engineers break down data to train smarter models. And so in machine learning, we don't necessarily just feed raw data directly into our algorithms, you know? Just like an audio waveform doesn't tell you much on its own, raw numbers don't mean much without meaningful features to be able to tell the context and background. And to kind of visualize this, I want to share this white noise or white sound generator. So over here, we're gonna generate some white noise. Even if you don't know what it is, it's fine. Just focus on hearing what the sound. Alright, so this was definitely some cool music, different from what you've kind of heard in the scores. But if I were to tell you jot down what you heard, what was something meaningful, unique about it, it would be pretty hard to. Why? Because there's not much structure or meaning to it, or divisions to it, like there was for our other songs. And that's what we call in machine learning unprocessed data. No structure, no meaning. But now, what if we have another pretty random beat, but now we can extract these quantifiable features that describe what it really is. So, by the way, this tool we're using a spectrogram, which kind of outlines the different frequencies. Hmm. So notice, this was also a pretty unique sound. And if I were to tell you jot down what features you kind of heard, that would also be kind of hard. But what we're doing is that we're quantifiably looking at these different things, like for example, bird sound. And through those different textures, colors, and frequencies, we can kind of make it what song is, right? And so what what that's doing is that it's helping us see through these um, precise precise ways and representations of looking at something that can be so abstract. And that's how we process machine learning. We take this data, we take out these features from it, and use those features to extract patterns, and use those patterns to be able to predict whatever it is that we want to our machine learning to be able to do. That's kind of the whole generalized process. Without features, none of that would really be able to work in the way that we'd like to. But also keep in mind, it's good features that matter, features that tell you information. Like this bird. You can tell stuff about the sound. Colors can tell different things. Your frequency wavelengths are depicted by the height. We can tell things about it. Like what if I just told you um that for our feature we're going to be using the the time it took to set up the song or the time it took to record the song. That doesn't help us analyze what the song is. So that's a very simplified example, but one crucial component of making these features to be able to process this data is thinking of relevant features that are applicable directly to your project. And so, yeah, as a quick recap, without feature extraction, both machine learning models and music mixes sound like a mess. But next time you tweak a synth patch or mix a track, think of yourself as an ML engineer, shaping data for better results. Let me know in the comments what's your favorite part of the sound design, and don't forget to like, subscribe, and stay tuned for our next lesson on neural notes. Thank you.